Hello everyone. Welcome again to another Saturday live stream. As always, we're going to do a little audio check. So if you have any problems hearing me, then please write something in the comments, and then I'm going to try to get this sorted out. I'm at the same time also trying to see a little bit if I'm able to hear myself. Yes. Okay, there is a little bit of a delay of approximately 20 seconds or so, so I'm able to see myself also on YouTube. And here we are again, and I would like to welcome you again. It has been always a tradition a little bit. If you're joining in here and in the chat, then please. I would like to invite you to tell me from where you are, because it's become a little bit of a tradition over the last couple of weeks and months, because microscopy is enjoyed all over the world here. Okay, great. Yeah, loud and clear all over here. And from Asheville, North Carolina, I suppose. Hello from Germany. Okay, from the Netherlands, from Norway. I think all of you are able to hear me, from Iraq. And okay, hello again. Okay, Missouri. Okay, great. Romania. Isn't this beautiful? So thank you again for Scotland for joining in. Despite the fact that there is some kind of a soccer game going on right now. My children are currently watching the soccer game, and I think that a lot of people might be therefore not showing up here, because but it doesn't matter, because this live stream here will be of course available online as well afterwards. Okay, from St. Louis, okay, Arizona, okay, Scotland, great. From England, okay. So hello everyone. So what I've thought about showing you today is a so-called slide ringing table. I've got one over here, okay, and and from Texas, okay. And if you have any questions about anything microscopy related, even if it is a little bit off topic, as long as it is microscopy related, please post it in the chat box. I will try to answer it if I can. Sometimes it's a little bit off topic, but as long as it's microscopy related, I think it'll be fine, and other people might also be interested. So I would first of all like to show you here. This is a slide ringing table. It is made of pretty heavy material, I guess iron, quite heavy. And it's used to make the following, and I'm going to show you some of the slides. These are permanently mounted slides, commercial ones. They're quite old already, but it doesn't matter. And if you take out some of those slides, you're going to see that, they have a nice little black ring here. Some of them, not all of them, and the question is now why is that, and what's the purpose? And there are several reasons for this, and I would like to show you also an application today for making so-called dry mounted permanent slides. And I would say that if you do not, if you want to try it out yourself, don't rush out, buy a slide ringing table, but you can make one yourself. It is possible to use. I don't know if you still are familiar with those fidget spinners. These are these toys that kids used to spin around. I used to make a slide ringing table using a fidget spinner as well. So all you do is you mount a round CD on top of which fidget spinner, and you spin it, and then you can get the same result here. But basically, before I start preparing some of the slides here, a couple of explanations of why you would actually make something like this here. So a little bit of theory first. So first of all, the most obvious thing, it kind of looks nice, okay, but that is not the real reason. There are two other reasons, and one is it depends a little bit on the mounting medium that is used to make those permanent slides. Some mounting media do not completely solidify, so that this means they stay semi-solid. An example of this would be glycerin jelly or glycerol gelatin. This is a traditional mounting medium which is water-based, and which retains a little bit of the moisture, and this glycerol jelly mounting medium is used to mount very delicate water organisms, algae for example, some certain protozoa, because they're very sensitive to dehydration, and when they completely dry out, they shrink and they completely lose their shape. So the mounting medium that is used to make those slides is water-based, and it does not completely dry out. And if this is the case, then there is a problem because for long-term storage, because this means that depending on the surrounding moisture and humidity, water can diffuse in and out, and also there is a little bit the danger that if it is not completely sealed off, that the mounting medium might turn bad. I mean, there is a preservative in there that prevents the growth of fungi, but you never know. If you want to store a slide for a very long time, you have to seal it off to prevent an exchange of moisture with the surrounding medium. And because the mounting medium, it does not completely solidify, it kind of stays semi-solid, the ring also stabilizes, physically stabilizes the cover glass. So it kind of glues the cover glass to the slide. So that's the reason essentially why some slides have to be ringed. And in order to do this ringing, you use a slide ringing table. But I'm going to use the slide ringing table today to show you how you can make some dry mounted permanent slides. So that means slides without a mounting medium. Okay, and I just want to show it to you, and maybe some of you are more experienced with this. I have not been making a lot of slides here, so I'm just going to demonstrate this a little bit. So I'm not claiming that I'm the best expert in this. I've just been experimenting a little bit, but I just wanted to clarify that this is the reason why some of the slides here essentially are ringed. Okay, so if you are interested in buying this slide ringing table, to my knowledge, unfortunately, it cannot be bought over Amazon, but there is a British company called Brunel Microscopes. I put a link into the description, and they are selling this. So I'm not affiliated with them. I bought this here a couple of years ago, so it's also not a review that I'm doing here. I'm just using it, and that's actually the only place that I found where slide ringing tables are sold. Okay. I do not want to take it apart really, but if you take it apart, there's some screws in here. There is a little metal steel ball in there, which basically allows it to rotate very smoothly. And this platform over here, this is used to actually rest your hand so that you're able to use a brush. And then of course the slide goes in here, and then you're able to, you ring it. And these are kind of reference rings that allow you to make, these things here. Okay, so the question is now, what material am I using now to actually make those rings? Now the company did send me some paints that can be used. But they also told me they could not send me those that actually they were originally included, and they said if it's okay to use different ones, water-based ones, because they're not allowed to send paints with organic solvent. There are these new laws, so I said it's fine, but I prefer to use a simple regular nail polish. Okay, it's pretty cheap, actually very cheap. And what I've done is I've added a little bit of acetone to the nail polish. So that's basically the stuff that the ladies put on their fingernails. I've added a little bit of acetone here to make it more fluid and more liquid, so that it's actually able to spread more easily. Okay, so this is kind of the idea. And what I've done already in preparation, where did I put them? In preparation, I have already, I put them somewhere, and I don't know where. Here they are. I've already made some slides here, and in the center, if you see this little white thing here, it's kind of difficult to see. That's vitamin C. So I crystallized some vitamin C, and I would like to make a permanent mount of this. Okay, I can also show you how this is done. Actually, I did make some other YouTube videos as well on crystallization. But the thing is when you've got crystals of vitamin C or any other crystals, there is a problem that just the crystals like this, of course, if you touch it, you scratch them, and then they kind of rub off, and then you don't have them anymore on the slide. So you want to protect them somehow. The problem is if I now add mounting medium on the crystals, then the mounting medium, which contains either water or some kind of solvent, might dissolve the crystals. And that's basically bad, obviously. So how can I protect them by actually putting a cover glass on top without actually having to put mounting medium on top? So that's why basically I made a ring. I put the liquid with the vitamin C in the center here. I allowed it to evaporate. Crystals started to form. I mean, over here as well. You can see that not all of the rings are quite nice, but you see that the white stuff here, that's vitamin C. And then I can put a round cover glass on top. Okay, so there are those round cover glasses as well. I got one over here. I don't know if you're able to see this. Okay, and those round cover glasses go on top here, and then I'm going to paint another ring around it. Okay, so this is kind of the idea, and then I'm going to yeah, simply start from scratch, and I'm going to show this to you how it works. And I prepared those already because it does take a couple of minutes for the nail polish actually to dry. So for this reason, I prepared a few of them here. Yeah. Generally speaking, yeah, you need a steady hand, of course, and I found out that not all of the rings turn out very nice, and the reason is if it's not liquid enough, so you have to dilute it down. So I think that's pretty important. Okay, so that's pretty much it. I'm going to read again some of the comments here. Okay, yeah, hello from Scotland, hello from Arizona, the United States. Hi from Ron in St. Louis. Okay, from Derby, England, from Texas. Okay, from Michigan, and also from Honolulu. It's been a long time ever since I last visited Hawaii. I was a child at that time, but I've been there. So, so what we're going to do is the following. We're just going to start making a ring here, okay? So how we're going to do this? A small disadvantage of this slide ringing table is that those clips here are pretty strong, okay? So I think yeah, they're a little bit tight, so one has to be a little bit careful that they don't break the glass slide. But all you do is you kind of lift it up and you try to clamp it in, okay? And the other one here as well, and then you try to center it as good as you can, okay? Okay. So can you differentiate between right and left-handed vitamin C crystals? Okay, so that's refers to stereochemistry. I think if you should be able to do that if you have a polarizing microscope, and if you are able to adjust the angle of polarization, then you should be probably able to differentiate them. I have never tried this out. This right and left-handed refers to the chirality. This space, that's chemistry. Okay, so there is an image and a mirror image theoretically possible. However, vitamin C is only one of them. I don't know if it's on right or left, but this basically refers to the direction in which the polarized light is being turned. Okay, so I would say you should be able to. I don't even know if there is the other form is also considered vitamin C. Okay, so I'm just saying. Yeah. So so basically I centered the whole thing right now, and I can give it a spin, and let's give it a try here. Okay. So let's give it a try. So I'm going to take some of this nail polish here. Okay, and yeah. Again, I made this very liquid, okay? However, it does evaporate very quickly. So I spin it and I carefully touch it, and I'm able to make a ring, okay? And then what I do now is I simply wait and I let it dry, and then for a few minutes, and then apply a second layer, okay? To make it thicker. Now, why would you need that besides making permanent mounts? Okay, sometimes this is useful if you are looking at water organisms, and if they're a little bit larger, and then sometimes the cover glass might actually crush them. Okay, because of the how do you call this, the capillary actions, and water evaporating the cover glass, and the surface tension of the water will pull that down the cover glass to the extent that it might crush some water microorganisms, and sometimes this is actually something that you want, because you want to limit their movement so that microscopy is easier, otherwise they're floating around too quickly. But sometimes you don't want to do that, and by making those spacer rings, it is possible to protect them a little bit. So you can do a little bit something like a micro aquarium here. Of course, this also means that if the layer is too thick, then they might swim in and out of focus as well. It depends really of what you want to do. Okay, but these can also be used as spacer rings, and I don't know, I'm just going to try to apply now a second layer, hoping that the most of the acetone has now evaporated. And yeah, I'm using blue because it's a little bit one of my favorite colors, and it's easily visible. Of course, if you use clear nail polish, then it's more difficult to see. Yeah, I don't know. Yeah, it's very uneven that I applied it, so I'm going to use a little bit more liquid now. Okay, and let's give it another spin, and simply let it carefully flow on the slide. Okay, so I think that is more than enough. Okay, and I'm going to simply put it away, and I'm going to allow it to dry. Okay. Yeah. So I'm quickly going to check. Just a second. Let me quickly check my. I think there are 27 people watching right now. I just wanted to check how many people there are now online. Okay. So I'm going to take it off, and let's now try to put one of those other slides on here, ones that are already prepared, where there are the crystals already in the center. Of course, I have to make sure that everything is properly centered. And yeah, sometimes this takes a little bit of patience to get it properly aligned. And yeah, it's almost in the center. It does fluctuate a little bit. Doesn't have to be perfect, really. That makes it actually worse. So, I don't know. Yeah, it's okay. It doesn't have to be too perfect, but I guess I'll just leave it. Okay. Now let's try to put a round cover glass on top here. And now that's the important thing is the following, why the spacer ring is also important and why you actually do need a spacer ring. Without a spacer ring, there is the danger that because of capillary action, the nail polish is pulled beneath the cover glass. And if the spacer ring is there, then it's a little bit higher, and then the nail polish is not able to run quite as easily under the cover glass. So I hope that it is high enough and that it's not too liquid, so that the nail polish actually stays on the outside. Okay, this is kind of the idea. Sometimes what might happen is that when I apply the nail polish, that the cover glass is kind of moving to the side. Okay, so maybe it is a good idea to carefully use a little bit of nail polish here on the side. Okay, maybe also here on the other side. Okay, and you put the cover glass on top and you kind of glue it on here first to prevent it a little bit from moving. And I don't know, I'm just going to use, I've got some spoons here, and okay, so this way they don't move quite as easily because it's kind of glued on here, and now it's more easily possible for me to apply the nail polish. Okay, it's still not quite in the center, and I hope that this is stable enough. It does look stable enough, so let's give it a try. Okay, and yeah, I've not tried this yet. I'll be honest with you, I've not tried this yet, and I'm a little bit nervous of whether the nail polish actually is going to stay on the side or whether it's going to go in and be pulled in. So let's carefully apply a little bit of nail polish here. Okay, it's difficult to see. I think I need a little bit more. And so let's see if so. Yeah, I don't know if you're able to see this quite well under the under the camera or not. Okay, but I'm now basically applying the nail polish right at the edge of the cover glass, and a little bit is pulled in beneath the cover glass, but it should stay at the place where the ring is. Okay, it's a little bit for me as well difficult to see. No, but it's actually sealed off already. Okay, you might want to allow it to dry a little bit and maybe add another layer. Yeah, and yeah, then it basically should be hopefully fine. Again, this basically means that there is now air surrounding the crystals. That's essentially what I want. But of course, the cover glass protects the crystals at the same time. Okay, so I hope that this is okay. And then you just wait for a couple of minutes and then you allow it to dry. I don't know if it looks okay, I guess. Okay, yeah. You know what, I'm just going to try it with another one as well. Maybe this one here. Okay, so, and over here. And then, by the way, I'm going to show it to you also, of course, under the microscope. I have to kind of short disclaimer, those vitamin C crystals are a little bit too dense. They don't quite look as nice as some of my others that I made. But I'm just demonstrating here a proof of concept here. Okay. Maybe you could use another color for the second ring to see better if it is being applied. That's a cool idea. I didn't think of that. That's actually quite a nice idea. Thank you for the comment. So the suggestion is I used blue now. Maybe why not use yellow or some other red or some other color or black? Yeah, and then you basically are able to see better if it's properly applied. Yeah. Okay, another comment here. I'm getting my microscope on Monday, mostly to investigate water and mosses. We have the most diverse bioregion on this hemisphere. We have over 4,000 mosses. Wow, that's nice. Yes, lots of tardigrades to look for. Okay, yeah, and are there slides made commercially with this circular boundary? Yes. As a matter of fact, maybe you just joined in. So this is a question, are there slides made commercially? Yes, here, these are commercial slides. Let me quickly move this over. These are commercial slides, okay? And basically, I don't know exactly what they used here for material, but essentially what I just explained a few minutes ago is that they made this, even there is a mounting medium beneath it, so it's not air mounted, but you have to add this ring around it because the mounting medium is not completely solid. It's kind of semi-solid. Okay, and you need this ring to both stabilize the cover glass, and the second thing is to prevent exchange of moisture and from completely drying it out. Okay, because it has to stay a little bit semi-solid and it has to retain some moisture because otherwise the specimen is going to shrink too much. Okay. What about slides with a divot? Sorry, I do not know what you mean with a divot. Do you mean the concave slides? Is this what you mean? Sorry, I don't understand this. Okay. Is the thickness of the round cover glass the same as the square ones? Generally, you can buy different ones. In this case, it is. I think it's 0.17 millimeters. But I know that in microscopy, they have all different kinds of cover glasses. Maybe they're not easily available always online over Amazon. You have to go maybe to specialized shops that sell them. But in this case, they're the same thickness. In microscopy, at least in the professional microscopy world, they do sell cover glasses with different thickness, depending on the different applications that you need. Okay. I made a ringing table from a USB record player and an MDF disc. Works pretty well. Yeah, that's good. Yeah, works pretty good. Yes, I made one using it's my first try using a fidget spinner, which I kind of screwed on a wooden plate, and then I used a clamp to mount the wooden plate on the table. It also worked, and I put a CD-ROM on top. Yeah. David, a depression or small hole? Yes, there are indeed. There are slides. I don't have one right here right now. I have got someone in my cupboard. These are slides that are concave. They have a depression, and of course that's also possible. But you can do this as well. And however, those slides are a little bit more expensive. They're also thicker because there's this depression in there. But that should of course also work. And I've actually done this. I've used also the slide ringing table on slides with a depression. For example, if you want to mount sand samples where the sand grains are a little bit thicker, and you would like to put a nice cover glass on top. And the sand is dry mounted, so there's of course air there. You probably want to use a slide with a depression because those slides, the ring is not thick enough for sand samples, at least if the sand grains are a little bit thicker. Okay. Also, someone is watching in Canada, New Brunswick. Mm-hmm. So we have got this here. Let me just quickly try it again here, and. If any one of you have actually tried this before, okay, if you essentially want to, if you've tried this before, I'm now kind of losing this, then please also post a comment. I think I'm just going to put this here again. I'm going to glue it on a little bit. Yeah. Hi, Oliver, I have a problem with the 100 times objective when I observe water life. I can't see anything. Well, there can be several reasons. The 100 times objective, first of all, is an oil immersion objective. So this means you need immersion oil. And this is a little bit of a science to use. You have to be careful when you use immersion oil so that you do not contaminate the other objectives. And do not forget one thing, if you want to use the 100 times objective, then this magnification is already very high, and you need to have a very, very thin layer of specimen. Okay, because the vertical movement is going to be like this, that if something moves vertically, it's going to be immediately out of focus, and also the working distance, which is the distance between the objective and the cover glass, is very, very small. Yeah, so you need to have a very, very small amount of water, and I personally think that the 100 times oil immersion objective for water life, yeah, is difficult to use because of the movement of the water microorganisms. So in that case, I think the oil immersion objective for 100 times is useful if you look at static organisms like diatoms, for example. They don't move around so much, so it's much easier for you to focus. It could also be that you don't see anything because simply the concentration is too low, or you didn't close the condenser. There can be a variety of reasons. Okay, but generally speaking, yeah, the 100 times objective is a little more difficult to use. Okay, so hello from Greece. Okay, and yeah, so I glued on the cover glass here. And let's give it another try. Where is my previous one? The previous one I think is here. Okay, let's put this to the side, and let's give it another try. And yeah, the problem, maybe you can hear the sound a little bit. There is a certain speed where it starts to go into resonance a little bit, and where it's going to, yeah, it's starting to vibrate a little bit. That's a little bit of a, yeah. You see, and this is a, yeah, an example where it simply doesn't flow anymore. Okay, so you see that so, and here now there is too much on it here, but let's give it a try anyway. Let's give it a try anyway. Okay. Wow, this is a very thick layer. And also not, yeah. Yep. Let's see. Yep. Maybe the brush is also not the right one. Okay, usually you use much finer brushes. Yeah, and you see a little bit here. This is essentially what can happen. I think there is a little bit of the nail polish, too much nail polish, and it's now slowly being pulled beneath the cover glass as well. And that's something that you probably want to prevent, but it actually doesn't matter if it doesn't spread too much. It's fine. Yeah. So, this is basically a possibility of making dry-mounted slides. Where can this be useful besides just using crystals? For example, pollen. Okay. Now, pollen is in springtime of flower pollen. Normally, you use glycerin gelatin according to Kisser. Kisser's formulation. That means there's a certain ratio of glycerin and gelatin and so on, and this is used for pollen a lot. However, I've also made dry-mounted pollen slides this way. So basically, when you add a mounting medium, then sometimes the pollen, they start to swell because they absorb the water, and yeah, that's normal. But if you want to see the pollen in the dry state, then you can use also those air-mounted, dry-mounted slides. Okay. Okay, so so this is basically the thing here. You know what? Just for showing you a little bit of how this looks like, I'm going to switch over now to the microscope view here. I'm going to turn on, and again, these are now the vitamin C crystals. I'm not super happy with the way that they look. Okay, I do have a polarization system here as well, but yeah, because I think it's a little bit too thick. But you do see the patterns here. Normally vitamin C, it's too thick. Normally vitamin C really makes very colorful and beautiful patterns. But here the crystals are all a little bit very small. Excuse me. Yeah, and here you can actually see that here is a crystallization point. By the way, I do have an arrow right now. Okay, so here, it is here over here. There's a crystallization point, and then the crystal started to grow outwards. Yeah, and here, this blue part, of course, that is the nail polish. Okay, again, now it's protected because of the cover glass, but mounting medium would probably not have worked because they would have dissolved it, because vitamin C can dissolve in alcohol, which is slightly hydrophobic, and it dissolves very well in water. Yeah, so water-based mounting media are completely out of question. Yeah, and the only way to kind of preserve them is would be to put a cover glass on top like this. Yeah. Are there different kinds of thickness of slide glasses to buy just to easier watch specimens with higher magnification? Hi from Sweden, I suppose. Different kinds of thickness of slide glasses. So basically, the question I think that you're referring to, are there different thicknesses of these slides? I mean, the concave slides are a little bit thicker, but the point is that the thickness of the slide should not make an impact. It should not be relevant. What is important for the resolution is the thickness of the cover glass. So even if this were a little bit thicker, it should not make a huge impact. I know, probably it does have a little bit of an influence because of the light cone emerging from the condenser, but generally not to my knowledge that there are a lot of different slide thicknesses. Okay, but there are different cover glass thicknesses. Okay. Hallo und noch einen guten Tag. Yes, hello. I think your objective determines the cover glass thickness. To a certain extent, I will just show you some objectives have the value 0.17 written on them, and the 0.17, actually most objectives, refers to the cover glass thickness. And often the cover glasses, however, do not have a thickness of 0.17 millimeters, these are the units, but actually a little bit thinner, 0.15. Now that's kind of strange. Why would you actually, if the objective is calibrated for 0.17 millimeters, why are most cover glasses thinner than that? And the reason is because they account 0.02 millimeters, because the specimen is probably not touching the cover glass. It's a little bit down, yeah. And this 0.02 millimeters there, yeah, basically also has to be taken into consideration somehow. Yeah. So for this reason, the cover glasses, the normal standard thickness of cover glasses is 0.15 millimeters, even though the objectives are calibrated for 0.17 millimeters. But there are different ones that you can actually buy. Okay. If swapping the 100 times oil immersion objective, what would you advise, a 20 times or 60 times dry objective? Haha, that's also an interesting one. Generally, I recommend, I don't use the 100 times oil immersion objective very often. I think that if you want to observe a lot of water life swimming around, I think the 20 times is a very good magnification, because it still gives you a sufficiently wide field of view so that you're still able to see many of the microorganisms as they swim around. Okay, and a 60 times objective is better if you want to look into an organism, okay, which is stationary. So it depends a little bit of what you want to do. Both are suitable. It depends a lot on the type of microorganism that you want to observe. So for example, if you want to observe this larger microanimals like rotifers and tardigrades, I would consider the 20 times objective a very good magnification, because sometimes 40 times is already too large and 100 times is a little bit too low. So 20 times I like to use a lot actually. But then sometimes if you want to look into the cells, and if you really want to magnify a little bit more, then the 60 times is probably better. Okay, how does the light impact if from above or under the specimen? Sorry. Okay, so basically I did make other videos. Also do the following. Check one of my previous videos where I used a flashlight. I don't have one here right now, where I was actually shining light from the top. I actually do have a flash here. Okay, I mean, I know it's a little bit off topic. Okay. But I said it's fine if it is off topic, okay? Then simply because you were asking, I'm going to answer it. This is because you see, I'm in my real life, in my non-microscopy life, I'm a teacher, and students ask me all sorts of off-topic questions, and now I'm looking for a coin, okay? And I always answer them even if they're not directly relevant to the topic. So the question was now, how does light from the top or bottom influence it? Look, I put this here, 50-cent coin, okay? And of course you're not going to see anything, obviously, because there's no light able to go through. But look, with this flashlight, okay? Yeah, it's a little bit, it's too dark. You know what? I have to actually increase the brightness a little bit. So just a second. Configure video. I have to go into the thing. Oh, okay. I have to deactivate it. I have to configure it. It doesn't allow me to configure it now. Ooh, that's a pity. Okay. Okay. Unfortunately, the brightness is not high enough. But yeah, because I'm in the live stream, I'm not able to change the camera settings. Maybe I can change it on the camera itself. See, I now also discovered something. Yeah, so I just simply change the camera settings, and this is basically light coming from above. Okay, so it's a little bit. And if you want to just move this around, so just basically because you wanted to know. Yeah. So let's go back to the slide ringing table. Let's put this away again. So, yeah, I was actually showing you some of the things here, some vitamin C here, but I also have some other things that I wanted to show you. Let me quickly do this here. Now it's a little, see, now I have to change the camera setting again because it's too, which direction do I have to turn it? Because it's too bright. Okay, here we go again. Okay. Yeah, so yeah, again, my suggestion is if you want to do vitamin C or any other crystals, then yeah, make sure that the layer is very thin, okay? So if you have a thick specimen, it's better to look from the top, I guess. Yes, absolutely correct. It's not only a question of thickness, but also of transparency. So usually thick specimens do not allow any light to go through, and therefore it's going to appear as completely dark, and then you must have light coming from the top. And a classical example of this would of course be the stereo microscopes, which have light coming from the top. Okay, so that is basically, yeah, here, this here. I don't know if I just wanted to, because from the statistics, I always see that some people are always joining in later on. So for those of you just joined in, a very short explanation of what I'm doing right now again. Yeah, here these are commercial slides, which I didn't make, and these are called, yeah, these are rings here that are applied, and those rings can be applied using a slide ringing table like this here, okay? So what I wanted to do now, and I have to admit I did not try this yet, is I want to put some salt and some starch, what is this called? Cornstarch. I've got some cornstarch from my kitchen, and salt is also one of those typical specimens that you can only mount dry, or you use a resin-based mounting medium which does not dissolve the salt. Okay, so what I'm going to do now is, yeah, basically I'm going to apply a little bit of the cornstarch, and I'm going to try this again. So there are more questions here. 45 objectives plus 15 times eyepiece, does it really magnify 675? Then why should I buy a 60 times objective? Okay, a very interesting question, a very common question. The question is the following, is you get the total magnification by multiplying the magnification of the objective, I don't have one here right now, and the magnification of the eyepiece. So for example, this is a 10 times eyepiece, okay? And if you use now a 60 times objective, 60 times 10, you get essentially 600 times. And now why can you not just use a lower objective, powered objective, and a higher powered eyepiece? And the answer, very simple answer is, of course you can get the magnification, but it's going to be much more blurry. Okay, that is the reason why you have to, if you want to get quality, you have to increase the magnification of the objective. Okay, so that is the reason. It is correct. The magnification you can reach. I mean, for example, there are many microscope companies that sell microscopes. It magnifies 1,000 times. And how do you get this? You take a 40 times objective multiplied by 25 times eyepiece, and you get 1,000 times. However, the image quality is going to be much lower than if you were to take 100 times oil immersion objectives multiplied with a 10 times eyepiece. Yeah, you get the same magnification, but one of them is going to be much more clear. Okay, and that's the reason why yeah, it's important that if you want to go up with the magnification, you have to actually increase the magnification of the objective. Okay, can you use multiple rings on one slide? Yes, as a matter of fact, I have done this in some of the slides. I allowed it to dry, and then I applied a second ring. Okay, now I don't know if there is a use for actually making rings that are spaced outwards. I don't know if there would be a purpose for that, but as a matter of fact, this is actually what I'm doing. I'm applying multiple, or I have applied 2 or 3 layers on top of each other and always allowed it to dry a little bit. Okay, where can you purchase good ready-made slides, for example, parasites? Okay, now there are essentially, off the top of my head, 2 places where you can theoretically buy slides, a cheap one and a less cheap one. Okay, so the cheap place to buy slides is simply you go to Amazon and you buy yourself a box of ready-made slides from Amazon, and these are then general purpose slides which contain, I don't know, some animal tissues, plant tissue, cross sections of varying quality. Okay, but if you really want to have specific slides, also slides that kind of show parasites or certain diseases which are used for demonstration purposes for medical students, for example. Okay, I don't know, slides that show certain tumors even. for medical training, they need those slides. You have to go to a special company, and I think I don't have again. Oh, here, I need to get a paper to write down the address. Is called a German company called Lieder. No, I don't have paper. Just a second. No. Okay, I'm just going to write down the web address, and if you go there, you can download the catalog, and they have thousands of slides which you can buy individually. Okay, lieder.de. So that is the web address. They also have an English page. I'm not affiliated with them. Okay, they don't. I just know them because in school where I teach, we use slides from this company. You can download the catalog. It's a huge catalog, but please be aware they're not cheap, okay? Depending on what you actually want, okay? But that is simply something that I wanted to clarify here, okay? And this is where they have all sorts of things. So let me do now the following. I would like to have a look at a little bit at cornstarch. I have to admit, I never tried this before, okay? So I don't know how good it looks like, or not good it looks like. So, but this is basically cornstarch, okay, and I'm going to make a dry mounted slide here of this cornstarch. Then we're going to look at it, and maybe it's going to look totally boring, but then we've learned something that cornstarch is not very interesting. Okay, we'll see. So again, I will glue, I will glue this here again. Here a small drop here. And a small drop. I mean, just a second. Is this actually one where I actually already applied a cover glass? No, there's no cover glass on here. Luckily, okay. So, and let's put the cover glass on top. I already forgot where I applied the cover glass or not. I'm just going to use my fingernail, and let's give it another try. And again, I'm not this is the wrong type of brush to be used. Okay, this one actually, doesn't look nice, but it works. Okay, so by the way, I also did a scratch test. So the clear nail polish, provided that the slide is reasonably clean and free of grease, actually sticks quite well to the glass slide. Okay, so this is actually a good thing. Yeah. So let's have a look. Okay, and generally you always have to be careful when you put something under the microscope where there is still some fresh mounting medium or fresh nail polish on here. Okay, because you don't want to touch the objective. Okay, and here we go again. Let's have a look. This is now cornstarch. Let's see. This is actually. Actually, the starch grains look kind of. Well, they look actually nicer than and more regular than I anticipated. Look, I'm able to play around a little bit here also with the contrast. And let's change the. Okay, so that's cornstarch directly out of the box. You use this for cooking, when you make sauces, so on. Yeah. So the next one would be a 40 times objective. Ooh, okay. I don't like. You gotta be careful. Okay. And I'm not going to use the 60 times because I'm kind of afraid of actually dipping the 60 times objective into the wet nail polish. I don't like that. So here we go. So that is a dry mount of cornstarch, and the arrow is here. Where's the arrow? Okay, so you see the individual starch grains over here. Okay, How long do these ring slides last? I imagine a long time if they're not, if they don't get damaged. Okay, that's an interesting question here. Now those slides that we have over here, look. If you look here, this is typewrite. This is typed out with a typewriter. This slide box is from the 1980s. Okay, I guess. Look, many of the things here are even handwritten. Yeah? So properly made slides can last for a very long time. Okay, so yeah, so I think durability it shouldn't be an issue here. Yeah. So yeah, again, typed out with the hand typewriter. Yeah. So I use glycerin on the 100 times, and it also works. And I think you should also do this because the refractive index is the same, and also experiment with other fluids. Okay, so the idea is the following: instead of using immersion oil, to use glycerin. Because the refractive index is the same. Now I know that some microscope objectives are, as a matter of fact, also designed to be used for that. I'm not going to risk it on my microscope here, but yeah, why not? I mean, if for whatever reason it becomes damaged or so, yeah, it shouldn't be too expensive to replace the individual objectives. I mean, you go to AliExpress and you simply buy the objective directly from China. Okay, what did I do now? Okay, oh, I bumped against it, that's the reason, okay? Yeah, here, these are the starch grains from cornstarch, okay? You buy basically dry mounted. This disadvantage of this, of course, is the following: because they are suspended in air. You know what, I'm going to change over again. Because they're suspended in air, if you store them vertically, then of course it might be that they kind of fall down, okay? Yeah, but maybe, yeah, if it's very thin, then they're kind of compressed between, yeah, okay. So, and I want to try salt as well. Where's my salt? Okay, do I have salt somewhere? Here's some salt. The salt is a little bit thicker, so I don't know if, yeah, this is going to work so well or not. So I'm going to try this here, because this one is a little bit thicker. So, you know what I'm going to try now? I'm going to try something different now, which is something I'm going to apply another ring here first. And then I'm going to put the salt in here, and then I'm just going to glue the cover glass on top. Let's see if this works. Let's see if this works. So here I put the cover glass here. Cover glass are flying all over the place here. So let's try the following. Got some. Okay, on here I've got a little bit of a problem because my microphone stand is a little bit here in the way. So I have to find a, yeah. So let's have a look. So I'm going to apply a little bit of clear nail polish here. I hope that there is enough on here. Then let's apply a little bit of salt. Again, salt is non-polarizing, okay? So this is salt from the south of France. A couple of years ago I visited with my family over the holidays, and we bought some of the salt there from a salt mine. And let's put this one over here on top. I don't know if this is actually centered, and let's glue it on. Okay. I don't know. Nope. Okay. There was not enough on here, so it didn't work. So I'm going to try this again. Unfortunately, there is now a little bit of salt in here. Or maybe it already dried up. Doesn't look very nice. Or problem could be maybe the salt grains are simply too large and lift the cover glass to the extent that it's not able to contact the nail polish. Well, that's also an interesting experience. So you know what? I'm going to really try it now again with a lot of paint. This is highly experimental what I'm doing here. Okay. Oh, and we had the cover glass fly off. Okay, so we've learned something here, that essentially the ring has to be sufficiently thick, because I think the salt was actually too thick, and therefore the cover glass was not able to contact the nail polish. Okay, so this means we're not going to put on a cover glass now because it doesn't work, because I'd have to apply maybe 3, 4, 5 layers. But you know what? It doesn't matter. We're still going to try to have a look at it just for the fun of it, because I've never looked at this particular salt under the microscope before. And of course, you have to be careful. There's no cover glass now on top here. And yeah, these are basically the salt crystals. Yeah. I mean, I do notice now there is, of course, also one other advantage here, is that because of the ring, this prevents, of course, also water from spilling out. This might actually be also an advantage here. So if you want to keep the water, here's the ring. If you want to keep the water in one place, then this might actually also be, the ring might also be useful here. Okay. What time is it? Okay, 15 minutes, okay. Yeah, so next thing that I want to try out is I just want to try a little bit of a water sample as well. So not a permanent mount, but simply a water sample, and I would like to use now the ring as a spacer. Basically, this means that the cover glass should be held by the ring on the side, and I'm going to simply get a water sample. I don't know which one I'm going to use here. I've got some algae over here. Let's have a look at this here. Okay, there are some, a little bit of water and some algae in here, and I don't think that there are lots of interesting ciliates in here, because the last time I checked it was not so interesting. But okay, let's try it like this. Let's try to remove a little bit of the excess, and yeah, it's a little bit okay. And now we put the cover glass on top, and then we have to probably remove a little bit some of the excess liquid. Up. Okay, and what you're able to see now is that it actually worked out quite well. Is that the cover glass is now held above a little bit and does not completely crush the algae. Yeah, so it's a little bit of a thicker specimen that we have. If this is something that you want, okay, let's have a look here, and I have to remove this so that's again the 4 times objective, and here we go. Okay, they're individual cells here. Okay, and simply by focusing now, you can see that actually there. It's a little bit, everything's a little bit thicker now, obviously, because of the spacer ring. So unfortunately, not not a lot of movement here, but I hope that at least you get the idea. Okay. I made paper fudge instead of buying a centrifuge, and paper fudge go 15,000 RPM, and this is so simple. Paper fudge. What is this? Can you please explain this to me? There is one comment over here. I made paper fudge for a paper fudge centrifuge. I don't know how this works. This is kind of interesting. 15,000 RPMs, rotations per minute, is quite fast. Yeah? So it would be very happy if you could explain a little bit of how this actually works. I don't know what a paper fudge is. Okay. Yeah, but yeah, you get a little bit the idea. I hope that these paper, a paper fuge. How does a paper? That's an interesting one. A paper fuge. Is this? I know some people have made those centrifuges by pulling a string, and this was by when you pull the string apart, then a test tube starts to rotate. Okay, maybe something like that. Yeah. So this is this might be, that's an interesting. I never tried this. I've only heard about the concept, but I don't know how to make this. This is actually that's actually quite a nice project as well. A centrifuge that you can make by having a string that you rotate, and when you pull the string apart, then it unwinds, and this spins very quickly, and then you can kind of centrifuge things like this. Yeah. I just heard of it, that this actually is possible, but I've never tried it myself. Okay. Yep. So this is basically, I've got a lot of slides now over here. Okay. Yeah. So I don't know. You know what? Just for the fun of it, I just want to spend maybe 5 minutes or so. I'm just going to experiment a little bit now with the correct concentration and correct amount of nail polish here. So I'm going to simply try this. Let's try to use a lot of liquid. See, it's almost dripping. Okay, and let's have a see. If you use a lot of liquid, you actually get a very thick ring. Looks actually pretty nice. Okay, so this might actually be the solution here. Is to really use a lot of this, also thinned down with a lot of acetone. Yeah. Don't forget one thing, that when it starts to dry, then it will actually also shrink. And so the ring will become thinner, and then you simply have to reapply a new layer, right? And so this is kind of the maybe the correct way of doing that, or the best way. And there are actually dedicated paints that can be used, which I don't have, because they could not send it to me because of the mailing problem of chemicals that contain organic solvents. It doesn't matter. Okay, I'm simply going to use commercial nail polish. Could tiny gasket rings work? I tried, this is interesting, also what I tried is the following. I tried tiny rings as well. However, I had the problem of gluing them to the slide. Some of those rings were very absorbent. I think they were not made of rubber or so, but maybe I think some kind of a paper material, and they kind of absorbed all of the nail polish to the extent that it didn't stick properly. So I think it depends a little bit on the material, but this could work, and I've tried it as well. And I tried also to experiment around by stamping out cardboard rings, and I tried it with that as well. But again, because it was so absorbent, I could not actually get it to stick properly. And the reason why I tried it with cardboard rings is because I wanted to get a very thick ring, because I wanted to make permanent slides of sand samples, and to be used for stereo microscopy. Let's try this again. And see, this is already starting to dry a little bit, and therefore more pressure. So you see, I think the shape of the brush is also not the best one here. Okay, so gasket rings is something that I was also trying, considering, but somehow I have to make sure that it's so compatible with the nail polish and that it actually sticks properly. And it could be that sometimes maybe they're even too thick a little bit. So it depends a little bit on how thick they are, but sometimes you might need it a little bit thicker because you want to put in larger samples like sand grains and so on. Okay. In your previous video on sperm, can you put your own? I also tried it, also works. You asked me, okay, honest question, why did I not put my own sperm under the microscope? Because, I'll give you an honest answer here, because this video is also watched by students, and this would not be very appropriate. Okay, so this is one of the reasons why when I made a sperm video, I actually got myself some testicles from a bull, which I bought from a butcher. And I tried to extract sperm cells from there, and this was actually quite difficult to do. Okay, but if you want to see moving sperm cells, then honestly, you need a pretty decent microscope. I do have that, and I think it's not super interesting because many people actually do that already. And I think, so there is not a very high educational value to that. So this is one thing, and over here I want to simply now put apply a second ring over here. So and by the way, there are a lot of commercially prepared slides, because we were just talking about them, where essentially the slides are stained properly, they are cut properly, and this is all quite difficult to do on your own if you don't have the appropriate equipment. So therefore I do recommend generally a slide box with ready-made slides, simply so that you can look at certain things. right away. So this is something that I generally recommend. Yeah, again, if you kind of joined in a little bit later, I know that people are coming and going to this live stream over here. I just want to show you how to make those rings here, and these rings here are protecting the mounting medium on the inside, and it's also like this that these rings also stabilize the cover glass, and this way make the slide a little bit more storable. And however, today I'm using those rings here as spacer rings to make slides that contain samples that cannot come into contact with a mounting medium. Okay, so these are so-called dry mounted slides. And so if you are interested yourself in trying things like this, I highly recommend that you try to make something like this yourself. It's quite easy to do by simply getting some kind of a spinning table. For example, it could be a fidget spinner that I once made, or anything that is kind of free turning. You can get some ball bearings maybe. You make yourself a little disc, and if you don't have those clamps, you can use some tape to fix the slide. I think a slide ringing table really is only worth it if you probably if you make a lot of these slides, but for experimentation it might not be worth it. On the other hand, it was not so extremely expensive either. Okay, so do you guys have any more questions? Okay, I read that nail polish rings are not compatible with immersion oil. Immersion oil upon long-term contact with the ring can dissolve the ring and can cause swelling. Is it a possible issue? Short answer. Yes, that's possible, and you do not use immersion oil on permanent slides anyway. Okay, that is generally a thing. I mean, if you want to, you can, but generally you shouldn't, because sometimes because of the mounting medium that was used, it's quite thick anyway, and for using 100 times oil immersion objective, you need a very thin specimen. And if you start using immersion oil on permanent slides like this here, the oil is going to be all over the place. It's going to contact the slide labels. You don't want that. Okay, and then how are you going to get the immersion oil, the film of immersion oil, off the slide again? You should not apply pressure on the cover glass, because as I told you, that these are not completely solid, right? It's semi-solid. So it's like a thick gel, and you will not be able to get it properly clean again. So as a general rule, don't use immersion oil on permanent slides. Okay, I can quite well possibly imagine that some immersion oils actually don't respond well with the nail polish, and then when you get if it starts to dissolve it, and then if you get some of this stuff then on your objective, it's not the best thing for your objective. I read that can you make a video on making a paper centrifuge? I'd have to. Why not? I think it's an interesting idea. I've not tried it myself yet. I'd have to try it out. I'm thankful for any comments and recommendations on what to do, but I've not made one yet, so I'd have to figure it out. And sure, why not? Okay, thank you for the recommendation. Okay, so paper centrifuges are cheap ways on how to get very high rotation speeds, and we're able to centrifuge things. And the idea is to actually have it at low cost. Okay. So, any more questions, anyone? Otherwise, I'm going to leave it at that for today, because I am already starting to feel a little bit I have a little cough, and therefore have some problems talking a little bit. Otherwise, I'm going to I hope that you kind of enjoyed the video again, and it was informative for you. There are a few more comments here. I tried to stain white blood cells with methylene blue, leafless methylene blue. It doesn't work. What I found out, actually, it worked out quite well with me, but you have to mix it properly. Okay. So what I've seen, if you just put a drop of methylene blue with the blood, it's probably not going to be enough. So what I've done is I've taken a pipette, and you kind of mix it with a pipette, suck it in, and mix it properly. And then actually I got it to work pretty much all the time. So maybe that could be a reason. Okay. Okay, people from Scotland, England, Germany, Romania, Canada, Iraq, Norway, Netherlands, Sweden, Greece, and US watching Microscopy from Austria. A wonderful example of what the internet was meant to be. Thank you very much. That's precisely the thing that I say. Yeah? We're all, the whole world united in a common hobby. Yeah? And frozen water droplets in the freezer to look at them under the stereoscope. Yes, I do have a recommendation what you might want to try. I intended to do that also as a demonstration, but it didn't snow. Do the following: take some clear nail polish, okay, and spread some clear nail polish on a slide. I just demonstrate this to you, okay? So you put a drop of clear nail polish, and you do the following: the clear nail polish goes into the freezer first. The slides go into the freezer, really cold, okay? You take the ice cold, minus 20 degrees centigrade nail polish, you put it on a microscope slide and you spread it. You make a thin layer of ice cold nail polish, you catch some snowflakes and you let it dry outside in the cold. And then what you get is you get the impression of the snowflakes on the nail polish, and then you can put the nail polish with the impression of the snowflake under the microscope. Okay? So that's something that if you're living in a cold region, something that you might want to try. Yeah, so what you basically ice cold nail polish on a slide, make a thin layer, catch some snowflakes, let it dry in the cold. The colder the better, okay? Because sometimes if it's just around freezing, it's gonna melt when it contacts the nail polish, so it's gonna be really cold. And then you might be lucky that you're actually able to see some of the hexagonal patterns of the snowflakes, okay? So, how much should one worry about hurting the eyes when using eyepieces and experiment with things to change the light? Do you know of any pioneers in microscopy that hurt themselves? Yes, there is one way how you can hurt yourself, and that is by using a mirror and pointing it to the sunlight. Okay, some microscopes have a mirror, at least the traditional ones, and you don't want to look anything directly into the sunlight. That's number one. Otherwise, I don't see a big problem. Ultraviolet light, if you do fluorescent microscopy, might be an issue. But I think even researchers are actually using that. And there is this orange filter that is in front so that you do not get direct UV light. But this is not something that I'm actually aware of, that there should be actually some problems. Okay, but the big problem is looking into the sun, especially with telescopes. That's why they always have put the warning label. But I'm not aware of any issues concerning microscopy here. Okay. What is the best microscope? There is an easy answer here. The best microscope is the microscope that you will use most of the time and which produces most happiness. Just yesterday or so, I uploaded a video where I was sharing an email from a viewer who basically downgraded the microscope because he was not happy with the expensive one. Yeah, because he didn't feel comfortable with it because he was afraid of breaking it. Yeah? So you see, there is a lot of personal preference also involved here. And for hobbyists, it's the microscope that you like using the most. And if you're in research, then you have completely different criteria anyway. So this is then essentially, you have a whole catalog of criteria that your microscope has to fulfill. Yeah. Can you also make videos on stains and chemicals and also of some glassware? I could. However, I will tell you that I'm not using a lot of stains. I've been staining using methylene blue. I've been staining using fountain pen ink. I've been staining using also iodine for starch. But that's pretty much it. And the reason is because I like to most likely observe living organisms. And living organisms, when you stain them, then you actually kill them. Right? So staining is often used in histology when you, for example, I think you use hematoxylin and eosin if you stain cross sections of tissue because it stains red and purple. But this is not just a staining process. You have to have a complete preparation process, which actually is quite lengthy. But I can actually think a little bit about that. But the problem is obtaining those stains. Again, some chemical companies do not sell those stains to private people. They can be extremely expensive, some of the stains. And what some people, however, have been doing is using readily available sources, like, for example, Easter egg colors. Some red Easter egg colors contains carmine, which can be used to stain, for example, chromosomes. So that is something I can do, but I've also made some videos already in the past that show that. But actually, that's a good idea for a live stream in any case, because some people actually have asked me for this as well. Okay, I have traditional microscope. What do you think about it? What do you mean a traditional microscope? Used microscopes are perfectly fine. Some people actually like to use used microscopes over modern microscopes. It's also a question of preference. If it works fine, then that's good. If it is a very, very old microscope, a vintage microscope, like those brass microscopes from, I don't know, from the last century or the last 2 centuries, then I probably would not use them, because I think these are the museum pieces that should not be used because they're kind of too valuable. Yeah, they're collector's items. But otherwise, if you've got microscopes from the 70s or 80s, there are many people that still use them because these are high quality devices and could be maintained. And if you fix them and lubricate them and oil them and so on, there's no reason. Yeah. And as a matter of fact, some people prefer those used microscopes over modern microscopes. Yeah. So it's again a question of taste. Yeah. Yeah. Good morning. Yes. What is mirror or LED best? LED. Although this is something that you cannot say. Is a mirror better or LED? It depends what you want to do. Generally, I prefer. I mean, a mirror is of course then useful when you go outside, when you want to have portability. This can be a reason when you want to use a mirror. When you want to use an external lamp, there are a few microscope companies that do sell modern microscopes with mirrors. So there sometimes can be applications for this. But these days, if you want portability, then there are microscopes, good microscopes also available with LEDs, which are battery operated. Not just introductory microscopes, but also better microscopes that can be operated, not better is the wrong way, more advanced microscopes that can be battery operated. Yeah, so you cannot say that. Yeah. Okay. Hey man, what's up? I have a question. Once I bought a microscope to a river and I found a transparent worm. Do you know what kind of bacteria or living creature it is? Look, identification of organisms is a huge topic, and biodiversity is extremely large. So you have to do a little bit of research yourself, buy some identification books, and also be aware that if you actually get samples and specimens from nature, sometimes they can be quite rare, okay? So sometimes not all identification books might mention what they are. So this is something where I think microscopy and biology and studies of biodiversity kind of interlink quite well. And there is lots of things to learn there. And yeah, sometimes if you go into details, you have to be quite knowledgeable already, okay? So generally, bacteria cannot be identified with a microscope. So just by looking through a microscope, you cannot say, and you see bacteria, you generally cannot say what it is. Just like you cannot, I always use this example, you cannot identify the brand of a car by looking at its color. Okay, that's not going to work. Or you cannot identify the brand of a car, whether it's a Mercedes, BMW, Ford, by counting the number of wheels that it has. They all have 4 wheels, right? And the same is with certain microorganisms, especially bacteria. Just because 2 bacteria look the same under the microscope does not mean that they are related. Okay, so this makes it difficult. You have to do biochemical tests and DNA tests. Okay. Have you observed the effect of electricity on crystallization, avoidance or attraction of microbes? Yeah. So this is something that I would like to experiment around a little bit. There are so-called magnetotactic bacteria, which are able to respond to magnetic fields. Something I did not try yet, but I know that this exists. Something that I would like to try out. Have you ever viewed something that is totally blew your mind? I could respond to that a little bit like this. Every time when I look through the microscope, it kind of blows my mind a little bit to look at the wonders of nature. This is not something that you meant with your question, of course. Let's put it this way. There are always interesting things to observe, but so far it was not like this that I was completely overwhelmed, because I know already that nature is very diverse and that you can see a lot of strange things happening. Okay, that's essentially what I would like to say here. I want to recount a little story that I've encountered with a student of mine several years ago. I just gave her a slide with some onion cells because we were doing cell division, and she looked at the slide and she was, it blew her mind, and you could see it from her body language. She was shaking her head. Oh my gosh, yeah. And I said, what's the problem? And I says, there's so many cells under the microscope, and it's such a tiny piece of onion, and there's so many hundreds of cells, and it's so complex. So you see, that kind of blew her mind. The complexity, and you could look deeper and you see yet more, and you think that you already know the world, but actually if you put it under the microscope you see even more. And this kind of was really surprising to her, and this was something that for me it was kind of normal. Of course you're going to see a lot of cells, you know. Yeah. So you see, because I'm kind of already used to it, I already kind of know what to expect. Therefore, there are not so many big surprises. But on the other hand, every time when you look at something under the microscope, I say, wow, biodiversity is so high. Yeah? I want to review on BMS microscope. You have one. I saw it in the old video. This BMS microscope is honestly, it's a company, and there are essentially, this was actually a microscope that we had in our school. I don't even know if this one is still made, but often it's like this, that the same microscope is sold under different brand names. Okay, so I've actually had one which was then quite similar. I got a fantastic vintage Swift scope from Goodwill online for $62 shipped. Cleaned up perfect, great. Yeah. Thanks for the answer. Yes, I also recommend a video to show on home lab. I really want this type of video. Okay, a home lab. Honestly, my home lab is not so complicated. I do have a cupboard over there on the side where I have all of my microscopy equipment. I do have my microscope, of course, standing next to me, a monitor in front, and then here, a plastic cover so that the table is not completely white, so that there's a little bit of contrast. And I have downstairs in my cellar, I have a little bit a microscopy studio. So in this video channel over here, when you watch some of the other videos where you see me talk, then that's kind of a little bit my studio. Under quotation marks, it's actually not a studio, it's just a cellar where I have a corner, which I made appear a little bit nicer. Put up my 2 microscopes there so that it looks nice for the videos. So it really doesn't require a lot. And I deliberately, I bumped my microphone. I deliberately try to keep it a little bit simple, the whole thing. What's a hay infusion? A hay infusion is something traditional, something that you have to be careful with. Okay. So basically what people have done in the past is the following, is they've taken some dry grass, okay? And what they've done is they put the dry grass into water, into a jar of water, and they let it stand for a week. And then there was a massive bacterial growth happening. And you got to be careful with hay infusions because the bacterial concentration, it can become extremely high. Generally, you got to be careful. Okay, hay infusions are well known because traditionally they have been done back in the day, 1800s. People have made hay infusions to grow microorganisms, but it's like spoiling food. You know, the hay is food, or like spoiling of tea. There are lots of bacteria there, and you got to be a little bit. You don't want to mess with those, right? It's just like you don't want to mess with spoiled food. So I just wanted to clarify this. I just want to say thanks for your tips and looking at the snowflakes on the slides. Yes, I made a video of this in my other channel 1 year or 2 years ago. Okay, so please check my Microbehunter, my main channel, and I think it was last year or 2 years ago. I actually show you how I made some snowflakes and how you can actually look at them. Okay, I use this nail polish method. You got to check a little bit in my other channel and go back the video history, and then you're going to find the video. Okay, thanks again for another interesting video. Thank you very much for being here. Okay, I'll think of something again for next week. Hope that you enjoyed it. As always, wish you all the best. If you joined in late, the video will be available, of course, as always, online. Okay, I'm always happy for suggestions and for recommendations of what I should show you. I'm just going to leave it at that right now. Bye-bye around the world. Happy microbe hunting as always, and see you around hopefully next week again. Okay, bye-bye.